Hello students. The first chapter in 10th class is the real numbers. So here the real numbers is introduced in 9th class. So you know the numbers from the 6th class onwards. So that's natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So here, first of all, if you want to know what are the real numbers, so for example, if you take the number line, so if you consider the number line with the integers, we write 0, 1, 2, 3, 4, 5, so on. And if you write on the left side of the 0, we have -1, -2, -3, -4, so on. So these are actually, this is not number line. So these are only, here we are writing the numbers in an order. So no, but here this if you want to draw the number line, so you know that if you want to draw a line, so we have to join all the points together. Means a line is combination of a line is set of infinite points. But now here that line is not filled. Okay. So if you want to fill that line, so the remaining numbers also should know. So means between the 0 and 1, there will be infinite numbers. Okay. So there will be infinite numbers. Then how do you represent the numbers? How do you name it? So after 0, what do you get the number? What is the next number after 0? So or the again do you get integer? So if you consider the integer after 0, that's we have only 1. So 1 is the next integer to 0. But between 0 and 1, what will be the numbers? So that's one. You know that those are rationals and irrationals. Rational numbers and irrational numbers. So here in 8th class already you learned that between any two rational numbers there exist infinite rational numbers. Between any two rational numbers there exist infinite rational numbers. And also between any two rationals there exist infinite irrationals also. Means on the number line, if you fill this number line, so that number line is the set of infinite points, the set of infinite points. So every point on the number line, every point on the number line that represents a rational or irrational number. Every point on the number line represents a rational or irrational, an irrational number. Means every point is denoted by a rational or irrational number. So here that is either rational or irrational. So you know that the rationals and irrationals together we call as real numbers. That's why this number line is called real number line. Okay. So here whatever the numbers we are discussing, that is totally about the real numbers only. Okay. So we are not discussing about the only natural numbers, not only on integers. So here we're discussing about totally the set of real numbers. Okay. So here, if you consider the definition of the real numbers, the rational numbers and irrational numbers together, the rationals and irrationals together we call as real numbers. Okay. So here, if you consider the chapter, if you see the introduction in the chapter, that's given a wonderful point here. That is, God made the integers. All else is the work of man. So here, just now I told you the main point 0, 1, 2, 3. These are only in the integers, but remaining all in the between 0 and -1, or between 0 and 1, between 1 and 2, there exist infinite numbers. Okay, so those are called real numbers or rationals. Oh, and I told you already, every point on the number line, either it is a rational number or irrational number. So how many points will exist on the number line, that is line is combination or a set of infinite points. So that's why there exist infinite points between any 2 points. So each point represents a rational or irrational number. So here, according to this Leopold Kronecker, so God made only the integers, all else the remaining work totally we did it. Means as human beings, we did it. Okay. So there is a lot of research on the numbers. Okay. So here now I enter into the topic. So in your chapter real numbers, the first one, the most important is the Euclid division algorithm. Euclid division algorithm. So what is Euclid division algorithm? I want to tell you that. So here, if you consider here, this is the thing. Here it is given a simple equation. So A equal to BQ plus R. So here, don't feel this is the most difficult one. So why? Because this is already, yes. So that is called a division algorithm. So what is division algorithm? So let us see here. For example, if you divide a number 10 with 7, okay? So you know that 7 ones are 7 and the remainder is 3. Okay. Now this one, how to express in the form of an equation? I'm taking the 10. So here 10 and here 7 into 1. 7 ones are 7 and plus 3, the remainder. Okay. So here what? This is the divisor. What you call? The middle one is called divisor. This is called dividend. Sorry. This is dividend. And this is called 7 is called divisor. So this is the middle one is called dividend, and this is the number which divides the dividend is called divisor, and this one is called quotient, and this is called remainder. Okay, so here when you divide 10 with 7, so here you see 10 I'm taking here on the left side. 10 is a dividend equal to divisor into quotient plus remainder. Okay, so this is called a division algorithm. So here, what is what is there back of this? Means you have to say why we consider the Euclid division lemma. So what you have to consider? So what is that? For example, if you take these two numbers 10 and 7, if you're dividing 10 with 7, we take only 7 ones are 7. We don't take 7 to the 14. We don't take 7 0 0. So you have to take the nearest one, and means so here 10 we can, in the case of 10 and 7, we can write the equation only in this way. When there are for A and B here we consider A and B are called, that A is called dividend and B is called divisor. Okay, so we can find the whole numbers Q and R. Q is a quotient, R is a remainder. For example, I'm taking one more number 15. I'm dividing with 8. So you can take 8 ones are 8 and the remainder is 7 here. Write the equation dividend equal to divisor into quotient plus remainder. Okay. So here, according to the Euclid division algorithm statement, what the statement is, let us see here. So given positive integers a and b, for any given two positive integers a and b, there exists unique pair of whole numbers. Unique pair of whole numbers q and r satisfying a equal to pq plus r. Okay. So we discuss about this 0 less than or less than b. Okay. So what is this condition? Here this is the r is, that r is the remainder. So why it is given here? Why the remainder is, we have to consider only 0 less than or less than or equal or less than b. For example, if you are dividing any number with the 5, by dividing a number with 5, any number with 5. For example, I'm taking from 1 onwards. If you're dividing 1 with 5, we take 5 zeros as 0 and we get remainder 1. And if you're dividing 2 with 5, again the quotient is 0 and the remainder is 2. If you're dividing 3 with 5, again quotient is 0, 5 into 0 is 0, remainder is 3. And if you divide 4 with 5, again we get remainder 4. If you divide 5 with 5, 5 ones are 5, remainder is 0. And if you divide 6 with 5, 5 ones are 5, remainder is 1. And if you divide 7 with 5, 5 ones are 5, remainder is 2. 8 with 5, 5 ones are 5, remainder 3. And 9 with 5, 5 ones are 5, remainder is 4. 10 with 5, now we get 5 twos are 10, remainder is 0. Now 11 with 5, 5 ones are 5, remainder is, 5 twos are 10, remainder is 1. Okay, so here, if we consider the remainders, so what are the remainders here? 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. Means here you are dividing with 5. So you are getting the remainders 0. We are getting remainder 0 or 1 or 2 or 3 or 4. So you can take any number. For example, I'm taking 96, dividing with 5. 5 ones are 5. Yes, we get 46. 5 nines are 45. The remainder is 1. Now see, here we got the remainder 1. So means here you can take any number. You can take any number if you're dividing with 5, you get the remainder as 0 or 1 or 2 or 3 or 4. So if you're dividing with 5, would you get the remainder 5? You don't get. Why? Because when we take 10, we don't take here 5 ones are 5. We take 5 twos are 10. Okay. So and if you take 20 and take 5 fours are 20, remainder is 0. Means here this will continue. Means if you divide with 5, the remainders we get 0, 1, 2, 3, 4. Okay. And if you take, for example, let us take one more number. If you're dividing a number with 3, we're dividing a number with 3. For example, I'm taking 10. 3 3s are 9. Remainder is 1. If I take 11, 3 3s are 9. Remainder is 2. And if you take 12, 3 4s are 12. Remainder is 0. 13, 3 4s are 12. Remainder is 1. Means you see, when you're dividing with 3, we get remainders 0, 1, and 2. And if you take next 14, 3 4s are 12. Remainder is 2 again. And if you take the 15, 3 5s are 15. And the remainder is 0. Okay, means here when you divide with 3, we get the remainders either 0 or 1 or 2. So that's the important thing you have to remember. Okay, so here now let us go to this division algorithm. So what is division algorithm? Given positive integers a and b, for any two positive integers a and b, there exist unique q and r. Unique q and r such that a equal to bq plus r. Okay. So means here you understand that what are unique. Unique means a single pair. Okay. If you are taking 20 and 6, I can write A I am taking as 20, B I am taking as 6. And what will be Q? You can imagine 6 into what? What is the nearest number to 20? When you take the multiple of 6. 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24. If you take 4, we're getting 24. So we have to take 6 threes are 18 and we're getting only 18. So how much remaining? How much we have to add to get 20? That is 2. So 6 threes are 18 plus 2, 20. Okay, that's the thing. So and if you take, for example, 36 with 5, 5 into how much? You can take that 5 7s are 35, 5 7 are 35. Now here that is 35, we got 35. So what we have to add to get 36? That is 1. So 35 plus 1 is 36. Okay. So if you here you have, can observe that this is the dividend. Okay. So this is called divisor. This is called divisor, and this is called dividend. So you can always observe that this is the remainder. So this remainder is always less than this. Okay. There's always the remainder is always less than the divisor. Okay. And always less than divisor. Some cases you get that 0. When, for example, you're 20, you're dividing 5. 5 4s are 20. We get exactly. So there is no remainder. So that is 0. 5 4s are 20. So here, when you're dividing with 5, when you divide 20 with 5, you get the remainder 0. Okay. So that's the thing you have to remember. And here, what is given? This 20 and 6 we can write only in the form of this equation. Means there exists unique q and r, means when you take 20 and 20 as a and b as 6, we get q equal to 3 and the remainder equal to. This is called unique pair. In this case, you don't get any other. Okay, for example, I'm taking a equal to 40 and dividing with 8. Okay, so you know that a means that is 40. 40 equal to 8 into 5 plus remainder 0. So this is quotient and this is remainder. This is A, this is B. A, B, Q, R. Okay. Means for A and B, for this pair, there exists Q and R 5 and 0 only. Okay. So that is called a division algorithm and Euclid division lemma. Simply we call it as EDL. Okay. Euclid division lemma. Okay. So here for discussing the problems, sometimes I use the word EDL. Okay. So what do you mean by EDL? Euclid division lemma. Lemma means there is a statement or there's like a theorem. Okay. There is a uh, already proved one. And and here before this theorem, here we have one concept that is this do this. So here a equal 13 is given. What is the question? If you see the question, find Q and R for the following pairs of positive integers A and B satisfying A equal BQ plus R. Means, so for these given numbers, we have to write the division algorithm. So that's we can write very easily. For example, if you consider the first one, A, we know A equal BQ plus R. Means here we are taking A as the dividend and the divisor is 3. 3 into how much? Maybe if you take the 3 table, the nearest one, what do you get? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, plus 3 fours are 12. And we how much remaining? 1. So 3 fours are 12 plus 1. So you can think and write like this, or if you are getting some confusion, and for example, there are any bigger numbers, okay, if you here see, so those are bigger numbers. In that case, some students may feel trouble to do that. So that's why in that case, just you can divide and write 11. Yes, 11 ones are 11. How much remainder? Here that is 2. And here 2. 11 2 are 22. So when you dividing 132 with 11, we got the remainder 0. How do you write the division algorithm? A equal to BQ plus R. 132 equal to divisor 11, quotient 12, remainder 0. When there are bigger numbers, you can do this one in the rough work and you can write the statement. Okay, so that's the thing. Okay, so now let us conclude uh, the division algorithm and the remainder property. Okay, So according to Euclid division algorithm, for any two numbers A and B, okay. So here we take A and B as positive integers only. Okay, that's how to know number set. Now see, so here given positive integers A and B. So the condition is applied A and B. Okay, for given positive integers A and B, there exist unique Q and R such that A equal to PQ plus R, and here the remainder property is, that is the remainder is greater than or equal to 0 and less than the divisor. Okay, so here okay students, now you can tell me, when you divide with when I divide any number with 6, divisor is 6, what are the remainders? 0, 1, 2, 3, 4, 5. If you're dividing any number with 5, what are the remainders? 0, 1, 2, 3, 4. You know that divisor. Okay, so your remainder is less than or equal to 0 and less than 6 here. In this case, 0 less than or equal to or and less than 5 here. Okay, and if you're dividing a number with 10, what are the remainders, possible remainders? You know that 0 less than or less than 10, between and 0 and 10, and equal to 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so when you divide a number, any number with 10, we don't get the remainder 10. Just we get the number remainder as less than 10 only. Okay, so that's you should know. And one more thing to understand, to do the problems, the most important thing is to discuss the coming problems. That is the form of a even and odd number. Even and an odd number. So what is even? So you know that 2 into n. You know that even numbers means that's the numbers which we can distribute evenly. Yes, so evenly among two. Yes means which the numbers which we can make exactly half. For example, 18 is there. We can take 9 and 9. Or we can take from the childhood onwards, we're learning that the numbers which we can divide with 2 are called even numbers. Okay, so 0, 2, I'm taking integers, 6, 8, 10. These are all integers. So every even number can be written in the form of, can be written in the form of 2n. Okay, 2 into n. So what is n here? N is an integer. N is an integer. N belongs to z. This symbol is called belongs to. Actually, this one we get in next of the sets, but here we use the symbol belongs to. Belongs to. N belongs to z means n is a number that belongs to set of integers. For example, n belongs to n means n is a number that belongs to natural numbers. Means I'm from natural numbers, I'm taking that n. For example, n belongs to R means, so that is the 10 we are taking from the set of real numbers. Okay, the set of real numbers. And if you're taking n belongs to Q means n is a number that is taken from rational numbers, set of rational numbers. So I'm using n here, that's why I'm writing n. Okay, and if you take any letter we can take, for example, 2p, 2p. P belongs to Z means P is a number from set of integers. Okay, P means you can substitute 0, 2, 0, 0, 2 ones are 2. Okay, and 2 ones are 2, 2 is a 4, 2, 3 is a 6. Okay, we're taking integers. So, and one more, for any even number, if you add 1, we call that as odd number. Means here 2n, if you are adding 1. So these two forms you have to remember. That is the even number and the odd number. Even number form is always 2n, in the odd number form is always 2n plus 1. Okay, 2n and 2n plus 1. So that's the thing you have to know. Okay, so in the next video, we start with exercise number 1. Okay, I think you understood the Euclid division algorithm and some concepts and report the remainder. Okay, and how to write the division algorithm. Okay, thank you.